Hey everyone, welcome back. This is lesson 5-9, operations with complex numbers. Your objective for today, you're going to be able to perform operations with complex numbers. Your vocabulary for today is complex plane, an absolute value of a complex number. Just as you can represent real numbers graphically as points on a number line, you can represent complex numbers in a special coordinate plane. The complex plane is a set of coordinate axes in which the horizontal axis represents the real numbers and the vertical axis represents the imaginary numbers. I know it's kind of crazy, but we're going to have an axis, which is the vertical axis is going to represent imaginary numbers, and our horizontal is going to represent our real numbers. So let's take a look at that real quick. Okay, so here's our imaginary axis. You can see that our real numbers are going to be on the x-plane or the x-axis, and our imaginary numbers are on the y-axis. This is more just for information for you than anything. The real axis corresponds to the x-axis, and the imaginary axis corresponds to the y-axis. So think of when we see A plus BI, think of that as that you're going to plot that on your x-axis and this on your y, but you're not going to have to worry about plotting the I. That just tells you it's imaginary. So let's just look at a couple of these points real quick. It says graph each complex number. Okay, so the first one, A is 2, that's the real number, and then negative 3i. So we're going to go over to our 2 and go down 3 into the imaginary. 1, 2, 3. So our first point is going to be right there. That's our A. Our next one says negative 1 plus 4i. So we're going to go negative 1 on our x-axis and then 4 on the y. So our next point is going to be up here. And there it is. The next one says 4 plus I. So we're going to go over 4, up 1 for our I. And there that one is. And then finally, we just have negative I. So that means our x is 0 for our real. And then we're going to go to negative 1, which would go down. All right, and there's that point. Okay, let's just do a couple more. I'm not going to have you turn off the video, but you can look at it as we go. Graph each complex number. So we have 3 on the real. So we're going to go over 3, 1, 2, 3. And then up 0 for the I. So our point's just going to stay right there. 3 plus 0, I. The next one says we're going to go 2i. So that means we're going to go across 0 plus 2 on the I-axis. So we're just going to end up at here at our 2i. The next one says on the real axis we're going to go negative 2, 1, 2, and then down 1 in the I. So our I is going to be just 1 down 1 here. And there it is. And then finally, we're going to go over 3 and up 2, over 3, up 2. And there's our third point here. And that's all there is to it. Not too difficult. And I'm really not even going to ask you that on a test. Just wanted you to kind of be aware that there is actually an imaginary graph that you can plot these numbers in. Okay, now adding and subtracting complex numbers is similar to adding and subtracting variable expressions with like terms. Simply combine the real parts and then combine the imaginary parts. The set of complex numbers has all the properties of the set of real numbers. So you can use the commutative, associative, and distributive property to simplify complex number expressions. And I know that sounds really complicated, but anything you could do with a variable, you can do with the letter I also, the imaginary numbers. Let's just look at a couple of quick examples. Adding and subtracting complex numbers, add or subtract, and here it says to add. So what we're going to do is just, we realize that it's an A plus BI form. This is our A, this is our B, and this is our I. And they're both in A plus BI form. And I'm going to just remember that this is plus the opposite here. Okay, so the first thing we want to do is add our real parts and our imaginary parts. So here's our real, 4 and a negative 6. So 4 minus 6 plus, here's our plus sign, 2i minus or plus a negative 7i. All right, so we're going to add the real parts. 4 minus 6 is negative 2. 2i minus 7i is a minus 5i. Pretty simple. Okay, here's another example. The first thing we want to do, though, is we want to distribute. And what are we distributing? Well, this negative means actually times a negative 1. And we're going to distribute this negative 1 to get positive 2. And negative 1 times, actually that's a negative 3, is a positive 3i. Okay, so once we've done that, the next thing we want to do is group up our real numbers. Here are 5 and 2 are our real numbers. And then we're going to group up our imaginary numbers, negative 2 and a positive 3i. So we're going to put those parts together, and then 5 plus 2 we can see is 7, and negative 2i plus 3i is just a 1i. And there. Okay, let's just take a look at one more. It says add or subtract again. So the first thing we want to do is go ahead. We don't have to distribute a negative 1 this time. So let's just put our real numbers together. And so that's a 1 minus a 1. And then our imaginary numbers, let's put those together, negative 3i and a 3i. And we know that 1 minus 1 is 0, and negative 3i plus a positive 3i is also 0. So our total answer is simply a 0. All right, try this one on your own real quick. All right, you should be able to see this one pretty careful. We don't have any other real numbers. We just have a negative 3, and then we have a 5i plus a negative 6i. So we add our real parts together and our imaginary parts together, and we end up with negative 3, and 5i minus 6i is just a negative 1 or minus I. Here's another one for you to try. You just add these up together again. Our real numbers add together and our imaginary numbers add together. This time we want to distribute first. Remember, this is really a negative 1. So negative 1 times 3 is our negative 3, and negative 1 times 5 is a negative 5. So once we've distributed, we add our real parts together, which is negative 3. And then we have a 2i plus a negative 5i is going to be a negative 3i and a negative 3. So there's our answer. One more for you to try, adding and subtracting. Again, we don't have to distribute anything, so we know a 4 plus 4. And then we're going to add our 3i plus a negative 3i, and we can see that's going to be 8. The 3i minus 3i just turns to 0. Okay. You can also multiply complex numbers by using the distributive property and treating the imaginary parts as like terms. Simplify using the fact that I squared is equal to negative 1. And if you don't remember that, I squared is the same as square root of negative 1 times square root of negative 1, and that is the same as negative 1. Okay, so let's try one of these. The first thing we want to do is go ahead and distribute our negative 2i. So we're going to multiply negative 2i times 2, gives us a negative 4i. And then let's look, we have negative 2i times a negative 4i. So that's going to be negative 2 times negative 4 is a positive 8, and I times I is I squared. Okay, so let's not forget what I squared is. We just talked that I squared is equal to negative 1. So 8 times negative 1 is going to be a negative 8, and this negative 4i is just fine there. So it's going to be negative 8 minus 4i. And notice that I went and moved my negative 8 back over here, because remember it says to put in a plus bi, and 8, our negative 8 now, is our real number. It's no longer imaginary. So that's why we put it in this first place. All right, here's another one for you to try. This time we're going to distribute, and actually we're going to FOIL this. Okay, we're going to FOIL it. Remember, first terms, outer terms, inner terms, and last terms. So let's get going. The first thing we're going to multiply. So 3 times 4 is 12. 3 times negative I is plus a negative 3i. And there that is. And then 6 times 4i is 24i, and then 6 times negative 1 is negative 6i squared. Okay, so here we go. 12 is a real number, and 24i minus 3i is going to give us a 21i. Here it is. And we see that 6 times I squared, remember I squared equals -1. So 6 times -1, remember this is a -6 times a -1, so that's going to be a +6 plus 12. So we're going to get 18, write it in AB form, 18 plus 21i. So there it is. And remember, it's the real number plus the BI, A plus BI form. All right, try another one on your own here, or not really on your own. I'll do this one with you. 2 times 2 is 4. 2 times a -9 is going to be -18i. 9 times 2 is a +18i. And then let's look at our last term. So here's our -4, -18i plus a +18i. And then we have 9 times 9, and that's a -9, is -81, and our i's are squared. Remember, I squared equals -1. So 81, -81 times a -1 is going to give us a +81. And then let's just go ahead and fill that in. And our -18i and a +18i, they just cancel each other out, turn to 0. So all we have left is 4 minus 81 times a -1i. And if we think of this as -81 times -1, we know that it's 4 plus 81, which is going to equal just 85. And it says write it in A plus BI form, but we just have an A, so that's all we have to do. All right, this one's even simpler, more simple, okay? So we're just going to multiply. -5 times +6 is a -30, I squared. So remember, the I squared is the same as -1, so -30 times -1 is +30. All right, try this one on your own. Okay, so all we have to do is distribute our 2i. That's going to be 6i. I'm going to do it, but then we'll have it up there. Minus 10i squared. So first thing we do is distribute. Next thing, we remember that I squared is equal to -1. And there that is. So then when we just add this, remember this is -10 times -1, so it's actually a +10 plus 6i. But we have to write it in A plus BI form, so we're going to put 10 plus 6i. Another one for you to do, FOIL it out. All right, let's do this one together. The first thing we're going to do is distribute. And here we go. 4 times 6 is 24. 4 times a -i is -4i, or plus a -4i. And then -4i times a 6 is a -24i. And then -4i times a -i is +4i squared. All right, so there it is. And next we're going to remember that I squared is equal to -1. So let's get this piece filled out and fixed. And now 24 plus a -4 is going to be 20 minus 28i. All right. Try another one. Go ahead and turn the video off if you need to. Again, we're going to distribute first. And there it is. 3 times 3 is 9. Minus 6i plus 6i, and then minus 4i squared. Let's remember that I squared is the same as -1. The 6i and the minus 6i, they just cancel out to equal 0. So we end up with just 9 minus, or plus 4, because this is a -4 times a -1 is a +4, so 9 plus 4 is 13. All right, here we go. So the imaginary unit I can be raised to higher powers as shown below. So there's a lot of different ways you can do this. It says, notice that the repeating pattern in each row of the table. The pattern allows you to express any power of I as one of 4 possible values. It's either going to be I, -1, -I, or 1. So let's take a look at this. We know that I is equal to, let's see, I to the first power is equal to I itself. I to the second power, let's look at that, I squared. let's see, I squared is going to equal to square root of -1 times square root of -1, which we just have been talking about is -1. Okay, so I to the third. Now, I to the third is the same as I squared times I to the first power. And we know that I squared is -1. So -1 times I is -1I. All right, and we know that I squared times I squared for I to the fourth. I squared times I squared is -1 times -1, and that equals 1. So here are your four answers. It's either going to be 1, -1, -I, or +1. Okay, so if we were to go to 5, again, we could now just say, well, 5 is made up of I to the fourth times I. And I know that I to the fourth is 1, and then times I, so it's I again. Okay? 6 is 4 times plus 2, and so that would be the 4, which would be our 1, and I squared is -1, so 1 times -1 is our -1. Okay, so you can kind of see the pattern here. 7 is I to the fourth times I to the third. 8 is I to the fourth times I to the fourth. Okay, and 9, 10, 11, 12, you can see they're following the exact same pattern. Now, I don't always think of it in the same exact pattern. And another way that I think of it is I take my number and divide it by 4, anything past the first 4. So, and then whatever is left over, I could just come up here and fill in whichever one was there. So, example, if I have I to the 7th, all right, I sometimes say, okay, 7 divided by 4 is equal to 1, but I have 3 remainder 3. So I come over here and look at the remainder 3 pile, and I see that it's -I. And so 7 actually is -I. So that's going to come in a little bit more handy. You can do it either way, whichever way is more helpful. Sometimes to you, if it's like, or for me, I just write them out, -1 times -1 times -1. And then I might do this. I know that's -1, and this is I. So there's lots of different ways that you can think of this. We'll go through a couple of ways that I do it. Okay, here's an example. It says, simplify -6I to the 14th. Okay, so I put my chart up here, but we're going to do it their way, and then I'm going to show you my way. Okay, so first of all, and both the ways are really good. It says rewrite I to the 14th as a power of I squared. Okay, so instead of saying I to the 14th, I said I squared times to the 7th power. Okay, remember that I squared is -1. So -1 to the 7th power, that's an odd number, so it's going to actually be -1. So -6 times -1 is actually going to be a +6. So let's just look at that through. So here again they said, okay, I squared is the same as -1. -1 to the 7th power is +1. And so ends up being 6. Okay, what I sometimes do is say, okay, 4 goes into 14 3 times, that's 12, with a remainder of 2. Remainder 2. So I look over here at my chart, and I see that is going to be -1, which is right here. So -6 times -1 is +6. Either way works. All right, here's another one, 63. This is where I think my way gets a little bit easier, because I just say, okay, 4 goes into 63 one time, that's 4, 23, that's going to be 5, that's 20, with 3 remainder. So my remainder is 3. So I'm going to look over here, and I see that that's going to be -I. So I see this is going to be I it's going to be -I is what that answer is going to be. But let's just take a look at what it's going to be. So first of all, your book teaches you to rewrite as a product of I and an even power of I. So they're going to say I times 62. Okay, and then the next thing, rewrite I 62 as 2 to the 31st power. Remember now that I squared is -1 to the 31st power. That's an odd, so it's going to actually be -1. So it's going to be I times -1, which is -I. Okay, so that's all we have to do on that. Either way, however you see it clearly works. Let's try a different one. Again, I'm going to show you my way first, and then we'll follow the book's way, the way that they teach it. I just say 4 divided by 7, is 1 with 3 left over. So that is going to be negative I. And so I see that this is actually going to be -1/2 I. All right, so let's look and see how the book tells you to do it. It says rewrite it as, since it's an odd number, let's rewrite it as I times 1 to the 6th power. And now we can write 1 to the 6th power as a power of I squared. So 2 times 3 is 6, and that's how we get that. So I squared to the 3rd power is I to the 6th. And this 3rd power is it's odd. So again, it's going to be -1. And so all we have to do is say 1/2 I times -1 is equal to -1/2 I, which is what I got up here also. Okay, here's another example. Give it a try on your own. All right, you may remember that I to the 1st power equals I to the 2nd power equals -1, I to the 3rd power equals -I, and I to the 4th power equals 1. So here I have I equals I to the 42nd power, so I'm just going to take 42, divide it by 4, that'd be 1, that'd be 2, that's 0. So that is going to remainder 2. So I'm going to come up here, it's remainder 2. So I to the 42nd power is the same as -1. And so they tell you to rewrite it as a power of I squared to the 21st power. And I squared we know is -1 to the 21st power equals -1. And there it is. -1 to the 21st power equals -1. Okay, recall that expressions in simplest form cannot have square roots in the denominator. Because the imaginary unit represents a square root, you must rationalize any denominator that contains an imaginary unit. To do this, multiply the numerator and the denominator by the complex conjugate. Remember we talked about that, of the denominator. So all that's saying is, since we know that I equals square root of -1, if I have a number like 23 over I, that's kind of like saying 23 over square root of -1. And remember, we can't have we can't have a square root in the denominator, so we have to get rid of that. All right, so, and let's remember that the complex conjugate of a complex number is A plus BI. Okay, and the conjugate is A minus BI. All right, so there's a very important thing to remember. Our conjugate is A plus BI, and A is A minus BI. All right, here's one to try. The first thing we want to do is go ahead and multiply by the conjugate. So what is the conjugate of 5i? Well, the conjugate is going to be -5i. So once we find that it's -5i, we're going to distribute our -5i to everything. So -5i times 3 is -15i plus a -50i squared, I times I. And then 5 times 5 is 25, but it's negative, and our I times I is I squared. So once we distribute, then the next thing we should remember is that I squared equals -1. So we have a couple of I squareds in here. So we have a -50 times a -1 is equal to +50, and -25 times a -1 is equal to +25. So now we can see our new equation so far, or not equation, but our new numbers here. And now all we have to do is simplify. So we're going to say -15i over 25 plus 50 over 25. And I can see that 5 goes into 15 3 times, 5 goes into 25 5 times. 5 goes into 50 10 times, 5 goes into 25 5 times, 5 goes into 5 1 time, 2 times. So we end up with, over here, 2 plus a negative 3 over 5i. All right, hope that wasn't too challenging for you. Here's another one. Again, we have to find the multiplied by the conjugate. So this time our conjugate is going to be, if our number is 4 minus 2i, our conjugate is going to be 4 plus 2i. So we multiply the bottom times 4 plus 2i, and if we multiply it on the bottom, we have to multiply it by the top also, because really this is like multiplying 1 to the whole thing. Okay, so now we have to FOIL this whole thing out. Okay, so by distributing, we're going to do the FOILing. So 2 times 4 is 8, 2 times 2i is 4i, 8i times 4 is 32i, and 8 times 2 is 16i squared. Okay, and again, 4 times 4 is 16, and then notice this, they said 8i minus 8i, that's going to be 0. So then minus 4i squared, and so that's how we get that one. Now we're going to remember that I squared is equal to negative 1. So our negative 4i times a negative 1, that's going to make that a positive 4i, so that's going to give us a 20 down here. And then up here, remember this is a negative 1 times 16, so that's going to make that a negative 16, plus a positive 8, that leaves us with a negative 8. And then 4i plus 32i is going to be our 36i. So we end up with negative 8 plus 36i over 20. And I can rewrite that as negative 8 over 20 plus 36i over 20. And now I can reduce. 4 goes into that 2 times, 4 goes into that 5 times. And we have 4 goes into that 9 times, and 4 goes into that 5 times. So your final answer when we simplify is going to be negative 2/5 plus 9/5 I. Okay, so we just have 2 more to go. So let's try this one. Try it on your own for a second. Okay, the first thing we want to do is decide, we have to multiply by the conjugate. So if we have negative I, our conjugate is going to be I. So we're going to multiply everything by I. We have to distribute that. And so 3 times I is 3i plus 8i squared. All of that is over negative I squared. Now let's not forget that I squared equals negative 1. So I squared down here is negative 1 times a negative 1, because it's negative right here. So we actually end up with a positive 1, and then 3i plus 8i squared, and that's a negative 1, so it's going to be a negative 8. All right, so now we have 3i minus 8, but it's not written in a plus bi form, so we're just going to rewrite it to say negative 8 plus 3i. Okay, here's our last one to try. Turn the video off for a second and give it a try. All right, on this one, again, the very first thing we want to do is multiply by the conjugate. So if our number down here is 2i, we want to multiply by 2 plus I. And so we're going to multiply both the top and the bottom by 2 plus I. That's just another way of saying 1. All right, and then when we distribute all of that, we end up with 3 times 2 is 6, 3 times I is 3i, negative I times 2 is negative 2i, and then plus a negative I squared. And 2 times 2 is 4, 2i minus 2i is 0, and then the I times I is I squared, and it's minus. All right, so once we remember that I squared is equal to negative 1, we just fill that in, and we end up with 7 plus I over 5. And so to simplify it, remember it needs to be an a plus bi form. So we're going to put our real parts together and our imaginary parts together. And there you have 7/5 plus 1 over 5i. And that is the end of your imaginary lesson. Hope you have a great day, and I'll see you in class. Bye now.